for introduction, there are two parts in this experiment, which are part A, mud rheology determination using viscometer, and part B, determination of marsh funnel viscosity. Okay, for part A, rheological tests are made on fluids in order to help in deciding how this fluid can flow under a number of different conditions to achieve desired goal in drilling operations. The tests that are made regarding this is plastic viscosity, gel strength, and yield point in response to an applied force. Firstly, viscosity. Viscosity is a measure of a fluid resistance to flow. It describes the internal friction of a moving fluid. A fluid with large viscosity resists motion because its molecular makeup gives it a lot of internal friction. A fluid with low viscosity flows easily because its molecular makeup results in very little friction when it is in motion. Next, gel strength. Gel strength can be described in a drilling fluid as the measurement of interparticle force. Gel strength is the shear stress of the drilling mud that is determined after the drilling mud is static for a certain period of time at a low shear rate. The strength of the gel is one of the significant properties of the drilling fluid because it shows the capacity of the drilling mud to suspend solid drilling and weighting material where circulation is stopped. The third one is yield point. The yield point is defined as the stress beyond which a material deforms by a relatively large amount for a small increase in the stretching force. These forces depend on the mud's solid surface properties, the solid's volume concentration, and the solid electrical environment. The mud's yield point reflects its ability to remove drill cuttings from the hole. Okay, for part B, the marsh funnel, which is a conical shaped funnel, is used for a quick test of the viscosity of the mud on the rig by observing the time it takes a known volume of liquid to flow from a cone through a short tube. The marsh funnel viscosity is not a true viscosity, but it acts as a qualitative indicator of how dense the sample of mud is and useful only for relative comparisons. It shows viscosity variations and cannot be used to measure rheological properties such as yield point and plastic viscosity. So there are two objectives in this experiment, which are part A, to identify the viscosity, gel strength, and yield point of the sample, and for part B, to calculate funnel viscosity of the drilling fluid.
Next, move on to theoretical part. First thing is viscosity. Viscosity can be measured by the ratio of shear stress to shear rate. High viscosity fluids will have higher shear stress than shear rate. In this experiment, drilling fluid was tested under several flowing conditions by manipulating the rotation per minute of the propeller. After the drilling fluid has reached a steady flowing state, the viscosity is further measured by using a fan viscometer equation as stated below. Viscosity is equal to shear stress over shear rate.
Number 2 is gel strength. Gel strength is a function of interparticle process. In other words, gel strength is the ability of a fluid to suspend solid material when there is no fluid motion. High gel strength fluid has a very high viscosity, thus making the fluid has a solid state property that can hang or suspend solid through shear stress alone. Gel strength was measured by using the fan viscometer. The procedure takes place is that first mix the water with mud under 600 rpm for 3 minutes, then rest for 3 minutes, then mix again under 300 rpm. The first reading reflected was taken as the gel strength reading.
And last is yield point. Yield point is a resistance of initial flow of fluid or the stress required in order to move the fluid. It can be simply stated that the yield point is the attractive forces among colloidal particles in drilling fluids. The vectors affecting the yield point are the properties of mud fluid, the concentrations of solid in fluid, and the electrical properties of the solids. So yield point can be calculated by using the following formula, which is yield point equals to reading from a viscometer at 300 rpm minus the plastic viscosity. where the positive viscosity is equal to reading at 600 ppm minus reading at 300 ppm.
Next is the list of apparatus used for this experiment. Part A, rheology determination using viscometer. Is use barrel viscometer, mud sample, which is water-based mud, and mud mixer. Part B, determination of marsh funnel viscosity. Use the marsh funnel with receiving cup, mud sample, which is water-based mud, and mud mixer as well. Next is the procedure takes place in this experiment. For part A, rheology determination using viscometer is started with viscosity. First, drilling fluid was mixed for 5 minutes at low RPM by using the Hamilton beach mixer. The drilling fluid was poured into the sample cup to the amount corresponding to the predetermined bulb volume. The cup then was properly placed in the viscometer and the rotor sleeve is dipped to the EH line. Then the drilling fluid was stirred at 600 rpm until it becomes stable to read the torque. The dial reading was then taken from 600 rpm to 300 rpm in descending order. Each dial reading was recorded before shifting to the lower speed. Next, followed with jar strength. The water-based mud was stirred for 1 minute at 600 rpm. Then the mud was left to rest for 1 minute. The RPM knob was turned to 3 RPM and the maximum reading achieved after the start of the rotation was recorded. For U-point, the dial reading of water-based mud from the viscometer at 600 rpm and 300 rpm was recorded. The U-point then was calculated further. Part B, determination of marsh funnel viscosity. First, the orifice was sealed by a finger with the funnel in an upright position, and the water-based mud was poured to the screen until the mud exactly hits the bottom of the screen. Then the finger was withdrawn from the outlet immediately, and the time was measured in seconds for 200 ml of mud to flow out of the funnel. The reading from stopwatch was taken. The experiment was repeated 3 times in order to obtain average value, and the time needed for 200 ml of mud to flow out of the funnel was reported as funnel viscosity.
Okay, now we proceed with the result of the part A of rheology determination using viscometer. Here we can see the result for viscosity for oil-based mud and water-based mud, and here we can see also the graph of speed versus viscosity for oil-based mud and water-based mud, and here also we can see that the result of gel strength for oil-based mud and water-based mud. And then next, here we can see the result for the shear rate, shear stress, and viscosity for both oil-based mud and water-based mud. This is the calculated result. And then next, here the part B, the result of part B, definition of mesh funnel viscosity. And also here, we can see here the graph of the volume of mud versus time taken for oil-based mud and water-based mud. And here are the result for apparent viscosity, plastic viscosity, Bingham yield point, and true yield point for both oil-based mud and water-based mud. So next we continue with the calculation. So in part A, here are the parameter that used to calculate here, and then here are the sample calculation for oil-based mud, water-based mud. This is for to calculate shear rate, shear stress, and viscosity. Alright, next is the calculation for part B. Alright, here are the calculation for apparent viscosity, plastic viscosity, Bingham yield point, and true yield point. So there is a correction here for Bingham yield point. R300 minus it should be minus PV, not YP. Alright, sorry for that. Same both with the Bingham point at the water-based mud. R300 minus PV. Okay, for discussion, so there are two parts of experiment, which is part A, the mud rheology determination using viscometer, and part B, determination of mud funnel viscosity. So the objective of experiment part A is to determine the viscosity, the strength, and yield point of each of the sample, and the objective for part B is to measure funnel viscosity of drilling fluid. So for experiment A, the shear rate, shear stress, and viscosity of the sample are calculated and determined. In part A experiment, both sample data is calculated for all base mud. The highest value for shear rate are recorded is at 1031.8, and for shear stress is at 22.41 pound per 100 feet squared. So both of the highest recorded shear rate and shear stress can be seen at 600 rpm. Both value of shear rate and shear stress can be seen decreasing as speed rpm also decreasing. This means that both properties are dependent to the speed of rpm. However, as for the value of viscosity, the highest recorded for viscosity is 10.50 at rpm 600, and also at rpm 100 also recorded a high value of viscosity, which is 10.49 cp. Alright, for water-based mud, the properties are calculated. The highest value for shear rate is same as at 1021.8, and the highest value of shear stress is at 52.28 pound per 100 feet squared. Both of these value can be seen also at rpm 600. For calculated viscosity, the highest value obtained is astoundingly at 121.98 cpm, speed of rpm 100. So from the data we obtained, we can conclude that the water-based mud has greater value of shear stress and viscosity compared to oil-based mud. And in part B experiment, the experiment is to measure funnel viscosity of draining fluid. In this part, the properties such as apparent viscosity, plastic viscosity, behavior point, and true yield point are measured and calculated. So the hypothesis of the experiment is that the sample of OBM, oil-based mud, will take lower time taken for the sample to pass through the root tunnel when compared to the water-based mud. Alright, thank you.
In conclusion, for experiment A, oil-based mud shows when higher speed of rotation per minute used, the higher the shear rate and the shear stress of the mud. Water-based mud shows significant hike in values of shear stress and viscosity compared to oil-based mud. This is because of the properties of the water itself, which has higher initial viscosity than oil. For experiment part B, water-based mud has higher values of apparent viscosity, Bingham yield point and true yield point, but low of plastic viscosity compared to oil-based mud. This result shows that oil-based mud has better penetration rate and lower time taken needed to discharge the rock cuttings to the surface, but water-based mud provides better ability to lift the cuttings out of the annulus. The recommendations are: first, time taken for each sample should be supervised as they run to obtain better time result. Second, this experiment should be repeated several times to obtain more accurate results of both samples for both parts. Third, impurities present in both samples should be removed before the experiment starts. Fourth, The viscometer must be calibrated before the experiment begins to avoid reading error during the experiment. And lastly is the timing for the stopwatch must be done simultaneously for both samples as soon as the samples flow out of the funnel.